Alright, so in this video we're going to go over solving systems of linear equations in 3 variables. And by the way, the only method that we discuss for solving these kind of systems is the method of elimination. So yes, there's a way to do it using substitution, but it's kind of a tedious process. So in this case, we're going to do simply go over elimination method. Well, so the first thing that you might want to do is label the equations. So I'm going to label this as equation, use a different color here. I think good red's going to be a good color. So I'm going to label this equation 1, equation 2, and equation 3. Alright, so what you want to do here is, and this is key right here, eliminate in alphabetic order. That is, we're going to eliminate x's, then we're going to eliminate the y's in order to get the variable z. And then we're going to go back substitute to get y and then x. So let's see. So let's see what we're going to do first. So if it works, you might want to call this, if you will, step A. Part A, we are going to combine 1 and 2. Combine 1 and 2. Well, actually, yes, 1 and 2 to eliminate x. So you want to eliminate x first. Alright, so what am I going to do? I'm going to put together 1 and 2, equation 1 and equation 2, x minus y plus z equals a negative 4, and 3x plus 2y minus z equals to 5. Okay, so let's put these two equations together. And so we want to eliminate the variable x. So in this case, the coefficient of x on the second equation is negative 3. So what we need to do is multiply the first equation by the opposite in sign in order to get those coefficients the same but opposite in sign. So what I'm going to do here is rewrite the entire system. I'm going to distribute 3x, 3 times negative y, negative 3y, 3 times z. That's going to give us, well, actually, never mind, that's supposed to be negative, negative, and this is supposed to be positive. I don't know where I got that negative from. Alright, so that's going to be negative 3x plus 3y minus 3z equals to 12. Alright, and then the second equation remains the same. 3x plus 2y minus z equals to 5. Let's put curly braces to denote that these are together. So now we are ready to combine these two equations. Notice how the x's go away. And when we combine these two, we're going to add 3y plus 2y. That's a 5y. And negative 3z minus z, be careful, that's going to give us negative 4z equals 12 plus 5, that's a 17. Now this equation, notice it got reduced. It used to be a 3 variable, now we came up with one that has 2 variables only. Well, so let's label this equation as equation 4. We're gonna need this later in the process. So now I'm gonna do part B. Part B, we're gonna do something similar to part A, but instead of combining 1 with 2, what I'm gonna do is combine 1 with 3. Or you could do 2 and 3, but I prefer doing 1 and 3 because it's going to be more convenient when it comes to multiply one of the equations. So combine 1 and 3 to eliminate also x. Be sure that in steps A and B, eliminate x. I'm going to circle that. So notice we are eliminating the same variable. I'll show you why. This is gonna make a little bit more sense when we get there. So I'm gonna combine 1, which is x minus y, plus z equals negative 4, and negative 2x plus 3y minus z equals to 15. Okay, and then from here, well, we want to eliminate the x's. So in order to get that, I'm going to multiply both sides of the first equation by 2. So I'm going to rewrite this system. I'm going to multiply this by 2. That's going to give us 2x minus 2y plus 2, z equals negative 8. The second equation just remains the same, negative 2x plus 3y minus z equals 15. Let's put curly braces to denote that these are together. Add the equations, combine them together, see how the two x's go away. Alright, so let's combine the y's, negative 2y plus 3y, or 3y minus 2y, that's simply y. And negative 2z minus z is plus 1z equals 15 minus 8, that's 7. And in this case, let's label this as equation 5. Alright, so the next step, which you might want to call C, if you will. And in this case, we are going to do another elimination, another combination. We're going to combine 4 and 5 to eliminate. Well, in this case, again, we're eliminating in alphabetic order. We already did the first combination to get rid of x on both cases, right? So now we're gonna combine equations 4 and 5. Let's write them down. 5y minus 4, z equals to 17, and y plus z equals to 7. In this case, notice when combining 4 and 5, the 3 by 3 become a 2 by 2. So that's why we call it elimination, and because we already eliminated the variable x, what we do next is to eliminate the variable that follows in alphabetic order, in this case y. Alright, so now in this case I need to multiply the second equation by negative 5 to get that done, right? Because we want to combine, we want to have the same coefficient, just opposite in sign. So the first equation remains the same, 5y minus 4 z equals to 17. The second equation becomes negative 5y minus 5 z equals negative 35. Alright, now we are ready to combine these two equations together, in which the y's are going to get eliminated. So we combine these two together, negative 4z minus 5z, that's a negative 9z. And then 17 minus 35, that's a negative 18. And we're only one step away to get z by itself, and we get that by dividing both sides by -9, so z equals +2. So we have one of the variables figured out. Now let's go in retrospective here. We're going to use this value that we obtained for z, and we are going to substitute in your equation of your preference, either 4 or 5. So what am I going to do here instead? Well, in this case, we might want to choose the equation that looks easier to work with. And if you think about it, well, you are correct. Equation 5 is the easiest one to work with, because look at the coefficients of y and z. They're 1. Of course, if you want to work with number 4, make it a little bit harder, well, you should get the same thing, all right? I mean, but in this case, let's just go the easy way, the best way. So let's call this D. So for D, substitute C equals to 2 in 5 to find Y. All right, to find Y. So what we do, well, I'm going to write the equation again just so you can see where's everything coming. Well, equation 5, which is right down below here. So y plus z equals to 7. Well, I'm going to plug in this case, I'll plug in z equals to 2. So y plus z equals to 7 and z equals to 2. Simply in this case, subtract 2 to both sides, and y equals to 5. All right, now that we have z and y, all we need now is get our x. But in this case, we need to go way back to the very beginning, and you might want to choose between equations 1, 2, and 3, in which you will plug in a value for y and a value for z to get that of x. And again, as well, you might want to choose the easiest equation to work with, in this case 1. So what am I gonna do here is letter E, if you will. Substitute z equals to 2 and y equals to 5 and 1 to find x. All right, so let's write down equation 1 again, just so you can see where is this coming from. X plus, or actually minus y plus z equal to -4. So x minus y, which is 5, plus z, which is 2, equals to -4. Combining this together, we get x minus 3 equals to -4, and add 3 to both sides to get x by itself, which in this case is x equals to -1. All right, and as a final step, well, so what you might want to do is write this solution set as an order triple. Okay, that's F. Solution set. Okay, that's the order triple, -1, 5, and 2. So not an order pair like the systems of equations with 2 equations and 2 unknowns. In this case, an order triple. This is x, this is y, and this is z. Final answer to this. Well, maybe I should have used a different color. The actual color. All right. Okay, let's go ahead and look at another example. So for the next example, let's see. So we have an equation that apparently is missing some of the terms. Well, they're not necessarily missing per se. So what we have in this case is that 4x plus z, what we really have is 0y, a 0z, and a 0x. That's all that means. So don't freak out if you look something like this. Not that there's anything missing or any information missing. So label the equations. Actually, for this kind of systems, well, the amount of work is going to be less than that of the one that we just did. So number or letter A, actually, combine 1 and 2 to eliminate again. We are going to eliminate these variables in alphabetic order. Okay, don't forget that part. We go in alphabetic order. So let's see. So 4x plus z equals to 4, and then 2x plus 3y equals negative 4. So in order to eliminate x, what we want to do is multiply the second equation by negative 2 in order to get a negative 4, which eliminates the 4 on the top equation of this combination. So let me rewrite down the system. The first equation remains the same. The second one is negative 4x, and then negative 2 times 3x minus 6y equals to positive 4 times 2, which is 8. So when we add the equations together here, look how the 4x cancels with the negative 4x, and all we do is bring down these terms. Well, negative 6y, there's nothing else to combine it with, just bring it. Same for the z. And 4 plus 8, that's a 12. And let's call it as usual, that's our fourth equation, equation 4. All right, what's going to be part B for this? Well, so in this case, we don't need to combine 1 with 3, because notice what we got here is this fourth equation depends on y and z. So what we can do here is combine this equation 4 with an equation in the original system that has the same variables actually. All right, y and z. Did you see any of the equations? If your answer is equation 3, well, then you were right. So B, combine in this case 4 and 3, or 3 and 4. The order ultimately doesn't matter, but in this case to eliminate y. All right, to eliminate y. So let's see. So equation 4, which is negative 6y plus z equals to 12, and 2y minus 4 z equals negative 15. All right, so our goal is to eliminate y. So what we're going to do on the second equation, multiply both sides by 3. That way the coefficients of the y variable become opposites of one another, and that way we can eliminate. So I'm going to rewrite the system, this mini system, negative 6y plus z equals to 12. And in this case, when we distribute the 3, that's 6y minus 3 times negative 4. Be careful. Remember, we are distributing the 6 about all these terms. So that's going to be negative 12z, and 15 times 3, that's a negative 45. And we are ready to combine these two equations and eliminate the y's. Boom, boom. All right. So now it's time to combine the z's. So negative 12z plus a z, that's a negative 11. Z equals 12 minus 45, that's a negative 33. And yes, the numbers at one point started to look a little bit ugly, but the good thing, the sum after the rain here is these are going to go evenly when we divide both sides. All right, so that's going to give us z equals 3. Oh, really nice number to work with. All right, now from here we have two choices. We can use this value of z that we just obtained, and we can use that in equation 4 to find the value of y, for example, and we can then use it plugging in equation 1 to get the value of x. All right, so that's what I'm going to do next. In part, I'm going to call this part C. So part C, substitute z equals to 3 in 4 to find y. Okay, so let me write that down. Equation 4, let me write it again. Negative 6y plus z equals to 12. That way you can see where am I going to plug in this z equals to 3, which in this case is going to be right over here. All right, point it with an arrow just so you can see. So negative 6y plus 3 equals 12. Well, subtract both sides. Subtract 3 to both sides. That's going to give us negative 6y equals 9. And then divide both sides by 6. Actually, negative 6. And that's going to give us y by itself, which is negative 9 over 6. But actually, this fraction can be reduced to lowest terms. And whenever you get fractions as potentials part of the solution, be sure to reduce them, because if you're doing this on your MyMathLab homework, it's not going to take it as right. You need to simplify as much as possible. So y, this reduces to negative 3/2. I'm going to do a similar substitution for what I'm going to call part D. Substitute z equals to 3 in this case 1 to find x. See how if we plug in z equals to 3, we will be just ready to actually have x by itself. All right, so let's see. Let's write down that equation for x plus z equals to 4. So 4x, again, we're going to plug this in here. And then subtract this on both sides. Subtract 3 on both sides. So 4x equals 1, and divide both sides by 4 to get x by itself, which in this case is 1/4. And finally we get the solution, I wasn't able to show you this. Basically, subtract 3 to both sides, and then give us 4x equals 1, divide both sides by 4, and 1/4. All we need to do now for part E, if you will, solution set as an order triple. That's going to be x equals to 1/4, y equals to -3/2, and z equals to 3. Final answer here. Alright, let's do another example, some sort of special cases, if you will, for us, like example C. Let's see what's going to happen here. So, again, we're going to label 1, 2, and 3. And then, so I'm going to combine, as part A, combine 1 and 2 to eliminate x. Alright, so I'm going to copy those two equations, x plus y plus z equals to 2, and 3x plus 3y plus 3z equals to 7. Alright, so we need to multiply the first equation, in this case by -3 on both sides, and I'm going to rewrite the equation. So this first equation becomes -3x minus 3y minus 3z equals to the -6. Keep in mind that we are essentially distributing this -3 about all terms on the left hand side, and then this 3 on the right hand side. And then we're going to have 3x plus 3y plus 3z, which equals to 7. Look what's going to happen here. So when we combine these two equations together, the x's go away, the y's go away, the z's go away, leaving us with a 0 on the left hand side. And in this case, well, -6 plus 7, that's 1. In this case, we are essentially getting a bunch of mumbo jumbo, mathematical mumbo jumbo. Well, this is not true. This is a contradiction. When we have a contradiction right here, what does that mean? Well, no solution. No solution. So that's one of the cases in which the system of equations has no solution. There's another kind of case, which is going to be the one on the next page. Well, so let's do the usual label 1, 2, and 3. Part A, combine 1 and 2 to eliminate x. Alright, to eliminate x, so let's write x plus 2y minus z equals to 4. And then -2x plus 3y plus z equals to -4. So what we want to do here is eliminate the x's, and we can get that by multiplying both sides of the top equation by 2. Alright, what is that going to do for us? Well, in this case, what it's going to do is give us the opposite sign coefficient. So when we combine this together, we get those x's eliminated, as it is our ultimate goal. Alright, so far when we do this, well, negative 2x plus 3y plus z equals negative 4. Again, keep in mind that we are distributing the 2 about all these terms. So all we do next is eliminate the x's, combine the y's, that's going to give us a total of 7y, and combine the z's, giving us a negative z equals 8 minus 4, that's 4. And you might want to label this equation as equation 4. Alright, nothing crazy so far. Nothing crazy so far. Well, let's look at part B. So for part B, well, we're going to combine. Well, we already did the combination between 1 and 2. Now we're going to do the combination between 1 and 3. And we are going to eliminate again the same variable x. So combine 1 and 3 to eliminate also x. Alright, so combining 1 and 3, x plus 2y minus z equals to 4. Combining with the third equation, that's x plus 9y minus 2, z equals to actually 1. Alright, so all we need to do here is, either way, you can multiply the first or the second equation by negative 1. That's going to do it. Well, I'm going to do, I don't know, the second one. I'm going to do the second one, multiply by negative 1 on both sides. So let's see what's that going to do for us. X plus 2y minus z equals to 4. So multiplying by negative 1 on both sides of the equation, essentially what it does is change the sign of everything. So negative x minus 9y and then plus 2 z equals to negative 1. And we are ready to combine these two equations, get rid of the x's, and combine the y's, finally combine the z's and then the constant terms, giving us a negative 7y and then plus z equals to 3. Call this equation 5. Alright, so now that we did combinations 1 and 2 to eliminate x and 1 with 3 to eliminate x, we obtained two equations that depend on the same two variables. Alright, so what we're going to do next is combine combine 4 and 5 to eliminate y. So let's write down equation 4, which is 7y minus z equals to 4, and equation 5, which is negative 7y plus z equals to 3. Well, in this case, these two equations are ready to just be combined together and giving us another mathematical mumbo jumbo here. You know, so that cancel the y's, cancel the z's, giving us a 0 on the left hand side, and 4 plus 3 equals to 7. And yes, this is baloney. Alright, 0 is not equal to 7, so for this reason, no solution. Well, let's compare and contrast this couple of examples. So let's compare it with C. So, example C gave us a contradiction and no solution on barely the first combination of 1 and 2. All right, so the minute we got this contradiction, we were ready to just call it a night for this guy. However, for letter D, it took us the two combinations at the actual elimination of the first variable, which is obtaining the 2 by 2 system in order to get that no solution. So just a little bit more of work to essentially get the same kind of solution. All right. Now let's look at another case. Let's look at another example. Well, let's see. Let's label 1, 2, and 3. And what we're going to do here is the following. Part A. Combine combine 1 and 3 to eliminate x. So let's write them down. X minus 2y plus 3z equals negative 5, and negative 3x plus 6y minus 9z equals to 15. Alright, let's combine these two together. Let's try and eliminate the x's, and we get that by multiplying both sides by 3. Alright, so let's see. So when we do this, well, let's rewrite the systems, and we're going to get 3x minus 6y plus 9z equals negative 15. The second equation remains the same, negative 3x plus 6y minus 9z equals to 15. Look what's going to happen here. So a lot of stuff, actually everything is going to get eliminated, giving us 0 equals to 0. Well, in this case, as opposed to the previous example, this was a contradiction, which means no solution. But over here, otherwise, we have a true statement telling us that this equation has infinitely many solutions, but not just yet. It could be a little bit deceiving, if you will. So the combination 1 and 3 is telling us that we have infinitely many solutions. Now, what about the second combination? We need to make sure that we also get the same thing here. So we're going to combine 1 and 3 to eliminate x. So what is that going to give us? Well, let's write down these two together. X minus 2y plus 3z equals negative 5, and 2x minus 4y plus 6z equals to negative 10. So in order to get this eliminated, well, we need to multiply the first equation by negative 2 on both sides of it. So this is negative 2x plus 4y minus 6z equals to negative 5 times 2. That's a negative 10. And then the second equation, just bring it, remains the same. So essentially all we did is distribute this negative 2 about all these terms. All right. So the second equation, we didn't do anything to it. Well, actually, this is supposed to be positive, and this one is supposed to be negative. All right, and look what's gonna happen. So When we put these two together, boom, 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 and boom, boom, everything cancels. So we also get the same 0 equals to 0, which tells us this one has infinitely many solutions. Well, the solution set C all we do for this is open curly braces and then write down x, y, z such that, and all you have to do is copy your favorite equation. That's all you have to do for this case. X minus 2y plus 3, z equals to negative 5. And then close the curly braces. So when you do this homework part on MyMathLab, so you're gonna have three options. Number one, the actual order pair like the first two examples, no solution and infinitely many solutions, one of them being this, the case. All right, and the other one, and in this case, all you will have to do is you will be given all this notation. You will be given this part blank to just choose your favorite equation. So why can you choose any of the equation? Because any equation that you type is essentially the same equation. These two are multiples of the first one. All right, and well, possibly the one that might be the most involved of them is going to be case F, which is going to be an infinitely many solution, but it's going to be expressed in a slightly different way. Well, how is this going to work out? Well, you will see here. So, well, we're going to label the equations as usual. And then let's combine. Part A, combine. And combine 1 and 2 to eliminate again. We go in alphabetic order as always. Eliminate x. So x minus 3, y minus z equals to 4, and x minus 2y plus 2, z equals to 5. All right, and in this case, well, let's multiply the first equation by -1 on both sides in order to have opposite sign coefficients. So let's rewrite the system. That's going to give us -x plus 3y plus z equals to -4, and then x minus 2y plus 2 z equals to 5. This one remains the same. All right, we're ready to combine these two equations together, and x's go away. Combine the y, so 3y minus 2y, that's 1y, and z plus 2z, that's 3z, and 5 minus 4 is 1. And you might want to label this equation as equation 4. All right, letter B, part B. Combine one and 3 to eliminate also x. Remember, and when we do this combination, we need to eliminate the same variable so that when we get the reduced equation, they both depend on the same y and z. All right, let's combine those equations. X minus 3y minus z equals to 4, and 2x minus 5y plus z equals to 9. So what are we going to do in this case? Well, in this case, the coefficient of x is 2. In order to cancel them, x's, we need to multiply by the opposite in sign, in this case, -2. So let's rewrite the system again, distributing these two about all these terms. So that's -2x plus 6y rather, and plus 2z equals to -8. And 2x minus 5y plus z equals to 9. Essentially, the second equation remains the same. So we are ready to eliminate the x's, and 6y minus 5y, that's only 1y, and 2z plus 1z, that's a 3z, and -8 plus 9, that's going to give us a 1. And you might want to label this as an equation 5. So what are we going to do for part C? For part C, combine 4 and 5 to eliminate well, we already got rid of x in the first couple of combinations, and now what we're going to do is to eliminate y. Okay, let's write these two together, but if you look at them, they're exactly the same equation. So all we need to do here is multiply by -1 on the first one or the second one. Either way, it doesn't matter. I'm going to rewrite the system -y minus 3z equals -1, then y plus 3z equals to 1. When we put this together, when we add them together, boom, 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 and boom, boom. Everything goes away. 0 equals to 0, just like the second equation. All right, before finishing this problem up, let's compare with the previous example. Well, on the previous example, we got this 0 over 0, 0 equals 0, right from the very first steps of the combinations. So in this case, we didn't need to get the 2 by 2 in order to find out that this one had infinitely many solutions. So in this case, we just got them right away. So for letter F, in this case, we needed to get the reduced system before we noticed that we got the same, that we got 0 equal to 0, and therefore infinitely many solutions. Now, what are we going to do in a situation like this? Well, it's going to be a little bit more tricky to express the solution sets for these guys. So let's go ahead and do it. So let me write this down. So when let me use a different color here. Let me use red instead. When a system has infinitely we need to write both x and y in terms of z for this particular case. All right, so what are we going to do here? Well, in this case, when we get this 0 over 0, keep in mind that 0 over 0, let me do that on the back side of the paper real quick. Well, 0 over 0 equals to 0 can mean it's the same as, it's a logical sentence, just like 1 equals to 1, or 5 equals to 5, or x equals to x, but in particular, the one that we want to find is that z equals to simply c, right? That's the one that we want to go with. So let's bring that back over here. So it means z equals to z, all right? That's what it means. Now, so for part D, in a situation like this, solve for y. In 4 to write y in terms of z. So I'm gonna go, well, actually 4 and 5 are the same equation, but I'm still referring this as 4 slash 5, if you will. They're the same equation, doesn't matter. So so that's a y plus 3z equals to 1. I'm going to move the z's to the right hand side. So cancel. Y equals to 1 minus 3z. All right. So now we got y in terms of z. For letter E, we're going to do something similar. So now in this case, we're going to go to the first equation. So solve for x in 1 and substitute what we got over here, y equals to 1 minus 3z, to write x in terms of z. All right. So how are we going to do this? Well, let's write down the first equation. Equation 1, x minus 3y minus z equals to 4. So we are asked to solve for x first. I'm going to move this. I'm going to add 3y to both sides. And I'm going to add z to both sides. All right. So x equals to 3y plus z plus 4. So what we want to do is to get x in terms of z only. But we have a y here. So that's why we need to substitute y equals to 1 minus 3z. So everything remains in terms of z. So let's see. X equals 3 times plus z plus 4. So 1 minus 3z, and then distribute this. 3 minus 9z plus z equal plus 4. Combine like terms, z's with z's, numbers with numbers. When I do this, I get x equals to 7, 3 plus 4 equals 7, and then minus 8z. Alright, so solution set. A solution set is going to be still an order triple. Now in this case, the order triple is going to look like this. Well, whatever we got for x, which in this case is 7 minus 8z, and then what we got for y, which is 1 minus 3z, comma, z is simply equal to z. Alright, so just for your reference here, this is x, this is y, and this is z. Alright, and this concludes this section. I'll see you on the next video.